Sumerian technologies, that's perfume making and soap making. Soap and perfume goes back to Sumerian, like many other technologies. Perhaps it may be surprising to some of you that the first cleaning agent was urine, human urine. Sumerians used to use urine for cleaning the textiles and also washing the animal hides, because when they tan the animal hide, after they slaughter the animal, they had to clean the fat and the dirt from the hide, so they used urine, human urine and animal urine as well. Now, if you look at the structure of urine, it contains 9.3 gram per liters of urea, and when you go to a toilet, sometimes it stinks because urine decomposes and forms ammonia, and what stinks is the ammonia. So we know that ammonia is a strong base, and you all know that strong bases are good for cleaning dirt. So it was not stupid for them to use urine, and it was also used much later than Sumerians. During Roman Empire, urine was always used to clean textiles. And the Eskimos, they used to clean their faces in the morning with their own urine. Sometimes people think that urine, but it stinks terrible, disgusting, but in future we will all clean the sewer system and drink our own urine, because in space shuttles and in space, the astronauts, they drink their own urine, not directly, of course, but they clean it up with certain processes, and then they get rid of everything except pure water, so they drink the pure water, and that is also used in some countries. Some countries clean up the purified water in the sewer system, like in London, in England. The water that comes out of your tap in the kitchen is treated urine and the water system. But of course, the astronauts, they do not use the water from the bathroom directly, only the urine they purify. But in London, they purify the entire sewer system. Well, anyway, so sorry.
Şey diyor ya, amonya gaz hidrojen formu amonyum hidroksit. Yani insanların herhangi bir yerde akıyorsa amonyadan bahsettikleri şey aslında amonyum hidroksit mi oluyor yani? Yani suda çözülmüş amonya diye bir şey yok mu aslında?
When ammonia reacts with water, it forms ammonia. Pure ammonia is in the gas form.
Yes.
It is there, but when you say ammonia, it is ammonium hydroxide. There is no pure ammonia. It's always ammonium hydroxide, okay? Because when you keep it here, after a while, on a dish, it will turn out to be...
Akıyorsa amonya o zaman amonyum hidroksit.
Yeah, sure. So since it's a strong base, it cleans up the dirt, because when we say dirt is oil, and there are some dust on it, or other substances. So the basic thing in the dirt is oil. Therefore, soap cleans up the dirt. Now, during Roman Empire, there were some people who washed. Even today, we have cleaners, right? So the people who were cleaning the sheets and the suits or the dresses of the people, they had washing houses, and their cleaning material was human urine. And they are called fuller houses. They had no soap at the time. Their urine was the only cleaning agent. Even the richest people, even the emperors.
Hocam, şimdi urine kullanıyorlar dedik ama urine su mu ekliyorlar? Nasıl yapıyorlar?
No, you use it just directly. You don't have to. If you want to, you can add, but it cleans up. So if you put too much water, it doesn't clean. So I don't know how they do it, but you can use it directly because as I gave you, the percentage of ammonia is not too high.
Banyo sütlerine sürerek mi yıkanıyorlar? Nasıl?
Yeah, they use it directly, yeah. For the dress, now they had big containers on the street corners, the fullers. Çamaşırcıyız. Biz nasıl açacağız?
Hocam dışarıdan açılmıyor. galiba.
Ha pardon, biri mi vardı dışarıda? Ha, kapıyı vursaydın keşke, ben anlayamadım, arkadaşlar anladı. Kapıdaki şey varmış, problem, arıza var. Geç. Hı hı. So they collected the urine by passers, anybody walking on the street. If they want to go to the toilet, there is no toilet there. So they had big buckets. They peed into the bucket, and then the fullers collected them once in a while and then poured it into their big containers, and they used it directly. So they were earning lots of money because many people gave their sheets and dresses to fullers to clean it up. And they were very rich people. But of course, when you are rich in any country, what do the governors of the directors of the country do? What would you expect the emperor to do to those rich people? What do you expect?
Increasing the prices, maybe.
Yeah, taxes. Yeah, they said we'll tax you. So this is a real original Fuller's house, which is, of course, it went under restoration in Pompeii, because in Pompeii, you know, most of the buildings are in good condition because they were, after the volcano, they stayed in good condition. Now the Roman Emperor Nero, you know all about Nero. He is a famous emperor, and he's supposed, huh?
He's the mad one.
Yeah, everybody, you know, knows that he was the man who actually, supposedly, we don't know for real, that he burned the city and then he was playing harp or something like that. But we don't know how true it is, but everybody believes into that. He was a madman, that's definite. Yeah, he was not a very well liked emperor. And he decided to collect tax from the fuller owners, the washers, and the name of the tax was vectigal urina. But after a while, he was criticized by the other people in the government and the family and also the noble people, so he had to quit collecting tax. But then later, another emperor, Vespasian, he also decided to collect tax from fulleries, from the washer houses. And then he was also criticized, and especially his son criticized him. Titus criticized him, but he said, smell this money. It doesn't stink, even though it comes from urine. And then he said, money does not stink. This became a famous saying all over the world. And in Italian, it was pecuna non olet, means it's a very famous saying in literature. It is still known. It means money doesn't stink. Now, they also used it as toothpaste. They mixed it with pumice. They obtained the mixture which looked like our toothpaste, and they washed their teeth with that. And the women used to wash their faces to have a softer skin. And as I said, Eskimos were always washing their faces with their own urine. Now, Sumerians used some of the plants and minerals as natural soaps. I mean, they did not only use urine. Usually, urine was used in factories where they produced hide, but we don't know when they switched from urine to plants, but they were the first civilization in the world who used something which is very similar to the soap that we use today. They used soda, because soda was abundant around Mesopotamia and especially in Egypt. So they used soda, sodium carbonate. It's a good base. Can anybody explain why sodium carbonate is a good base? From the analytical chemistry courses, anybody can tell me? We have sodium carbonate. Why is it strong base? Anybody who received AA from analytical chemistry? Kim aldı A? Analitikten A alan yok mu?
Enes var.
He?
Ben aldım hocam.
He?
Ben aldım.
Evet.
Hocam
Okay, when I write down maybe the carbonate, it will tell you something. Okay, I'll give another hint. What happens?
hidrojen nedir hocam?
Hmm?
Hidrojen nedir?
Plus?
Aslında bir hidrojen daha da oluyor ama hidroksit oluyor.
What is hydroxide? Strong base, right? Of course, not as strong as sodium hydroxide, but it's a strong base. So soda was used and still is being used as a cleaning agent. In the old days, when soap was not strong enough to clean some dirt, they used to add soda. I don't know if some of your mothers still add soda to the mixture when they wash some dirty clothes. Yok mu soda? Evlerde yok mu soda artık? Okay. It was very common because, we'll talk about it later on, because now they all use detergent, they don't need soda anymore. But in those days, they had to, I'll explain to you why they needed something else next to soda for very dirty clothes or dirty body. If you have grease or something, the soap doesn't clean it so easily. Well, anyway, but they use other things. The soda was obtained from one lake to many countries. It was exported because one lake is a soda lake. Then they used also Fuller's earth as a natural soap. Fuller's earth in Turkey we also know it and use it. It is similar to bentonite. It's a kind of clay, white clay. I think ceramic people use it. Ceramic artists use it. We call it kedi toprağı. You all know kedi toprağı, right? And bebe toprağı and pekmez toprağı, çamaşır kili. It is composed of, hayırdır? Ara sıra bu oluyor her nedense. Composed of magnesium and aluminum silicates. So does it give you a hint when I say magnesium and aluminum silicates? So it seems to me that silicates are good cleaning agents. Do you know any silicates at all? Can you name some of the silicates or some materials which contain silicates? Sessizlik. Well, I just mentioned that the clay. You can wash with your hands by the river. If you are a villager, you wash your hand by the river by using the mud. It's actually clay. It's silicate. There's something else. I don't know if you know what it is. Cam suyu. Have you heard cam suyu? Sodium silicate. Did you hear or not? Cam suyu hiç duymadınız mı? Sodium silicate. It's a liquid. Silicate is of course the main ingredient of quartz, which is one of the hardest substances in the world, and the glass also, silicon dioxide, right? But of course, in glass we have some other compound which makes it easier to melt. But quartz has very high melting point, but window glass is much softer. It's easier to melt at lower temperatures because of some of the impurities in it. Well, anyway, so when you obtain the sodium salt of silicon, you obtain a liquid which is used in industry for various purposes. So silicates are very common. Perhaps they are one of the highest we have the highest percentage of silicates on Earth. Everywhere is full of rocks, clay. They all contain silicates. So in the nature, they could find many silicates to clean their dirty dishes and clothes. Okay, so of course, everywhere in the world, these materials are known to be good cleaning agents. They also used some plants in Turkish. It's soap wort, which is sabunotu. Has anyone heard sabunotu? No? Okay. The villagers know it well. I'm sure that now they don't care anymore because they always go to easier way. They use soap. It's more practical because you have to go by the river and then pick up some sabunotu and then wash it up. So they don't want to go outside to collect some sabunotu probably. In Turkish, it's called çöven. Çöven otu, karga sabunu, köpürgen. So its roots contain some saponin, and saponins are also cleaning agents. They are natural surfactants. Now, we'll give you this as a homework. What are surfactants and what they are used in industry? What are surfactants and what they are used for in industry? Var mı duyan daha önce? Anybody heard what surfactant is? It's used very often in industry, many technologies. So soap wort or çöven otu, this is the picture of çöven otu or soap wort. We have the flower and the roots. They are both used. We have several, not too many, but there are several Sumerian tablets where they explain the details of making soap. In general, they used sesame oil with uhulu ash to make soap. I said ash. Uhulu ash doesn't matter. It's something rich in compound. What is the composition of ash? Why ash is used? Do you know anything about the structure of ash?
It contains magnesium oxide or something can be as base.
But magnesium oxide is not a base. You mean magnesium?
But
Magnesium?
carbon?
Huh? Magnesium?
Hydroxide.
Huh?
Magnesium hydroxide?
No.
Okay, actually, this contains magnesium.
Carbonate. It contains potassium and sodium carbonate. Potassium and sodium carbonate, ash. So ash is also used in our villages for cleaning. Hiç görmediniz mi köylü kadınlar? Köylü kadın da fazla görmüyoruz. Hepsi şehirli oldu şimdi. Okay, so it was always used, ash, wood ash especially was used for cleaning in all houses because it contains potassium and sodium carbonate. So potassium carbonate is stronger base than sodium carbonate. Okay, so they used ash and oil. That means they were using a strong base, not as strong as sodium hydroxide or potassium hydroxide that we use today, but still in those days it was the most proper material to use. So ash and oil, when you boil it, you obtain soap, but of course not as efficient as heating oil with sodium hydroxide. Okay. Then we have a tablet which is on the 7th century. It says castor oil, which in Turkish Hint yağı. Have you heard about Hint yağı? Do you know what Hint yağı is? Well, our mothers used to use it as a medicine also, but I don't think they use it anymore. They buy it for they.
Çıkarmak için falan
Efendim?
kullanıyorlar. Saç çıkarmak için.
Ne çıkarmak?
Saç kaş.
Onu duymamıştım. It was used as a medicine, especially for the children. They used to use Hint yağı. Okay. Another tablet talks about soap making, that uhulu ash, salt, oil, fat of cow. They mix. Now, we do not make soap always from olive oil. Most of the soap that is used in the world is sodium hydroxide plus animal fat. İç yağ. Olive oil, you can use it, but it's more expensive because olive oil is a very valuable oil. So when we talk about stearic acid, we usually are talking about, in many books, when you see stearic acid or glyceride, it is because most of the soap is produced from animal fat rather than olive oil. So olive oil soaps are more expensive today. In the old days, they were not, but today, since the value of olive oil went up, it's rare now to find real olive oil soap. So most of the soap that they use are from animal fat. Even in Turkey, they import animal fat. And then in the factories, don't think that they use olive oil. Efendim? Probably, yeah, just to say that it contains olive oil, yeah. So this is the Sumerian tablet, which gives the secrets of making soap that goes back 2,500 BC. That's about 4,500 years ago. And it's as a summary, it says boil uhul ash with sesame oil. There are many other explanations, but the important thing is that you have to boil or heat sesame oil with ash. Now, there are some medical tablets. There are not too many medical tablets, but there are some. This is one of them, a very famous medicinal clay tablet, which is in Pennsylvania, Museum of Archaeology and Anthropology. It gives various medicines, and it was found in Istanbul Archaeology Museum. It was transferred to Archaeology Museum. Somehow it went to Pennsylvania. It was, of course, excavated in Iraq. Iraq was part of Ottoman Empire. So when they collected towards the end of Ottoman Empire, the sultans ordered to collect some historical materials, and they established a museum. So many clay tablets in the world, of course, they are all excavated, mostly from Iraq, but many of them were in Turkey. We still have many clay tablets in Istanbul Archaeology Museum. So it gives a soap for medical uses, to treat your eye or to treat your wound on the body, wherever. So the soap works well because you get rid of the bacteria. So soap is a good medicine, actually. Since we use it every day, we don't catch bacteria. Bacteria cannot affect us as much as the old people because, the previous generations, because most of them didn't wash as much as you do. You wash your hand, your face, and you take a bath very often. In the old days, it was not easy to take a bath. You had to go to hammam maybe once a month or something. In the old days, they didn't know that you could take a shower every day. But in modern countries, even in Turkey today, not everybody takes a shower every day, but in many countries, people take shower every day. When you get rich, you can take shower every day. But when you are poor, it's difficult for you to waste your soap. They used to go to hammam once a month or so. Well, anyway, so soap is a real medicine because it's preventive medicine. If you are clean, it kills the bacteria. If you have some bacteria on your face or on your body, on your hands, it just cleans and kills the bacteria. Do you know how soap can kill bacteria? Why it kills bacteria? Because we'll talk about it, but when we talk about dirt, as I said, dirt is oil, and around it there are various things, and it sometimes it has bacteria. It just ruptures the membrane of the bacteria, just like alcohol. Alcohol, when you use sanitizers, because of COVID, it denatures the protein. So when the membrane contains protein, it denatures it, and then the bacteria just dies. And also soap kills, I shouldn't say kill, because viruses are not alive. They are active. They grow, but they are not living creatures or living cells. Soap attacks the membrane of the virus, coronavirus and all the other viruses, because their membrane is lipid, so it's oil. So easily they distract the membrane of the virus. Well, anyway, there is a simple, or maybe difficult to understand, but it's one of the simplest formulas of a medicinal soap. It was written around 900 BC. It says, vessel filled with water, tamarisk, ılgın in Turkish, sapwort, we said sabonotu, plating reed, it's a kamış, hırgü kamışı, uhulu ash, and beer, all mixed because of the alcohol. They add alcohol because alcohol kills the bacteria, as I said. And beer, all mixed. Man must drink pure water first. Then the prepared solution, which is the soap solution, poured over him. Then turmeric root, pure salt, pure uhulu ash, pounded, fat of crane, turna yağı, added. Patient body is rubbed with it 7 times. So we understand that the patient is ill, so they know that soap is good for bacteria. They don't know bacteria, but for some infections. So they decided to wash the entire body with a kind of mixture of soap, and they hope that the patient will get well. They say if it's good for your wounds and infection, it may be good for the whole body. So of course, we don't know what the patient's problem was, but they tried everything they could. Just like in Turkish, we say koca karı ilacı. When we say koca karı ilacı, it's a mixture of many herbs, many materials. If you mix 20 or 30 plants or some other compounds, if you are lucky, one of them will be good enough to treat the patient. But of course, maybe 90% of the time they don't do anything. But if it works once, then you become famous in the village. So, but of course, that all comes from Sumerians. Koca karı ilacı, we did not invent it. It all comes from Mesopotamia, from Sumerians. They heard that if you mix many plants, it's good. You produce a good medicine.
Hocam bir girebilir miyim ben? 7 kere yıkanır demiş ya, o dini bir şey olabilir.
Tabii dini bir şey, tabii. Tabii o zamanki 7 was always a respectable number. 7, like today. In all religions, especially in religions created in all the religions created from Mesopotamia. I mean, when we talk about prophets, it all created in Mesopotamia. Jewishism, Christianity, and Muslim religion. So they are all influenced by Babylonian history. No. In history, nothing is accidental. Yeah. Okay. They also made oil with castor oil, Hint yağı. And this is the picture of castor oil. We don't know, but definitely they mixed it with ash. Uhulu ash is rich in sodium and potassium carbonate. It's a kind of plant which still grows in Mesopotamia, or I think in Egypt. Well, anyway, they made mouthwash around 690 BC. We see a tablet. They prepare a soap as a mouthwash. They heat castor oil, uhulu ash, and then they use it to clean their mouth. And the strange thing is that soap was not only used for cleansing or cleaning textiles, it was also eaten on the table. I don't know if they were on the table, but wherever, on a dish, as a sweet, as a delicatessen. Because soap tastes partly sweetish. I don't know if you ever tasted accidentally the soap. There are some patients who actually eat soap. Their body wants soap, and I don't know if you ever met some person who's addicted to eat soap. It's very rare, but it's an illness. But it tastes slightly sweet. And the other thing is that in those days, they did not separate glycerin from the soap. Today in factories, we use the animal fat, and then as glycerin, we have to separate it. But later then they said this soap contains glycerin because it acts like a moisturizer, especially the women prefer glycerin-containing soap. They remove all of it, but some factories add some glycerin to the soap. In those days, they didn't, so glycerin tastes sweet. That's why probably they ate as a delicatessen, because in those days, sugar was not invented. So since they did not remove the glycerin, their soap was creamy. It was like a butter. But when you remove glycerin, it becomes hard. That's why we remove glycerin in the factories, to obtain hard soap. You all know that they sell sulfur soap today. So Sumerians were the inventors of sulfur soap. They say, take turpentine, terebinthine. It is from pine trees obtained. Sulfur, uhulu ash, and put them in water, then oil and spittle, saliva, tükürük. Our saliva contains antibacterial chemicals. So when you see some cats or some animals licking their fur, it's because they are cleaning their fur from the bacteria. They kill the bacteria. So sometimes you see some people, you know, when they have any kind of a problem on the skin, they just put saliva. It's not stupid. It works. So all saliva of all the animals contain antibacterial. Also, our eye produces antibacterial chemicals. Gözyaşı, tears. Also, they are good disinfectants. They kill bacteria. And that's how penicillin was invented, you know, accidentally. Because also your nose, when you have some disease and your nose keeps producing liquids, it also contains antibacterial compounds. So he had flu. Do you know the history of penicillin? No? Yeah, a British scientist was working on some bacteria, and then when he just laid on microscope, something came out of his nose, But he had to go away for a week for something else. When he came back, he saw that bacteria were killed in the petri dish. And he didn't understand what happened. He said, the only thing happened was, that, he did it maybe hundreds of times for other works, but this was the first time the bacteria was killed. He realized that his runny nose dropped into the petri dish and then killed the bacteria. Then they worked harder, and then soon they discovered how to produce penicillin, isolate and produce. So before penicillin was invented, you would die. If you broke your leg or arm or leg, you would die. If it bleeds, definitely you die because there is no treatment. It's gangrene. People died of gangrene because gangrene is bacteria, viruses, everything is growing there, and then it occupies all your body, and then you die. So all the soldiers wounded in the wars died, definitely died. In First World War, all died. If you were wounded with a simple bullet, you died because they didn't have penicillin. After the discovery of penicillin, people didn't die anymore. Okay, so don't think that your saliva or your runny nose or your tears are useless. They are useful. Okay. So the spittle are poured thereon and forming an ointment. Ointment, merhem. We also know that after Sumerians, Egyptians produced soap, but the only document or the earliest document is Eber Papyrus, which is written in 1550 BC. It's a very long papyrus. When you think about papyrus, you always think one page. They glued one on to other, then they had rolls. When in the movies, when you see Roman emperors gives rolls, that means there are many papyruses attached to each other or glued to each other. It's about 110 pages and 20 meters long. So they gave all the medicines that they knew. So 110 pages, they gave the formula of many medicines for many diseases. Of course, some of them were wrong, but many of them were correct. So there, they give the formula of soap as a skin medicine. Probably they add sulfur. I don't remember, I don't know. But it gives medicine for treating skin problems. This is one page from the papyrus. There are, as I said, there are many pages, 110 pages. They also they knew that sulfur soap was a good medicine if you had a problem or infection in your eyes. In those days, they were making eye medicine. So, it is amazing. 5,000 years ago, they were making, or 4,500 years ago, they were making medicine for eyes. I mean, they knew how to distinguish the diseases in different parts of the body. So they use potassium nitrate, iron sulfate, uhulu ash, ferturpentine, köknar terebentini, lipidium, it's kind of tere in Turkish, sulfur, and ox fat to make a special soap as eye medicine. So it definitely worked because they use some plants and also sulfur and soap. Sometimes they add various mixtures to impress the people. And they know that it works. Maybe, we don't know. I mean, actually, as far as I am concerned, they didn't have to put all those. Just soap would be fine. If not, sulfur soap would be just enough. The other materials probably was unnecessary, but they didn't know which one worked. So that's why they mixed lots of things together. So when you mix 25 materials, 2 or 3 of them works, the others are unnecessary, but you don't know which one of them works. Okay. So when we look at the soaps, they have similar chemical structures to oils and fats. Now, the soap is very similar to oil or fat because it is only the sodium salt of oil or fat. So that's why they work to clean the oil, clean the dirt. They are the fats and esters of long-chain aliphatic carbons. I'll give you the structures of some of them. They are long-chain fats or oils or fats or oils, sorry. We know that the textiles, when we wash textiles, they are sensitive to the pH of solution. So you cannot use everything for every textile. And when we check the pH values of some materials, we see that if the pH is between 0 and 2, they are mineral acid cleaners. They are good for very heavy stains. You don't use them all the time. If you have very heavy stain, you can use it. Mild acid, if you look at them, that's 2 to 5.5. That's inorganic salts, water-soluble metal complexes. And neutral ones are between 5.5 to 8.5. They are light oils, small particles. And if you use mild alkaline like 8.5 to 11, then you can clean oils, the particulates on it, and some films on the textile. If you use alkaline, which are stronger alkalines, that's 11.5 to 12.5, it cleans oil, fat, and proteins. Very alkaline or highly alkaline, then if you have heavy grease, then you can use it. So the pH of the cleaning agent varies depending on the dirt. So you don't have to use very alkaline solution for just normal dirt, but it depends. Now, if we have a textile or textiles made out of wool and silk, their monomers are proteins. So they are protein fibers. Then you have to use mild acids, not strong acids, or not strong bases, to protect the textile if you have wool and silk. Cellulose, they are cotton, they are cellulose-based fibers. You can wash them in any cleaning agent with mild alkalinity, maybe 7, 8, 9, or even 10. But cotton, wool, and silk, they are all destroyed if you use very strong acids and very strong alkalis. So you shouldn't use sodium hydroxide or sulfuric acid or hydrochloric acid because all the textiles will be destroyed, which is natural. Also the dyes, if you have very high pH or very, very low pH, then the dyes are decomposed. So you have to, that's why they control the pH of detergents and soaps in the factories. Now, in the modern factories, we do not make soap much different than Sumerians, but we know what we are doing. We know which composition is the best. So our factories are producing proper soaps, which will not be harmful to you, because if you use some of the Sumerian soaps, probably it contains very high amounts of alkaline compound like carbonate, or it could harm you. So in factories, as I said, they are sure about the pH of the product. As I mentioned before, if you remove all the glycerin, you get hard. But if you add a little bit, then it becomes a bit softer, and it is good for the body of human beings because it keeps the skin a little moist. But if you dry it totally, it would be difficult for you to stand that. Your body needs some humidity. Therefore, the suitable soap is better so that your body will be more comfortable. Now, if you look at the structure of triglycerides, you can see that we have glycerin and the acids are added. Now, I don't know if still the doctors talk about it, but many people who had cholesterol, they said, benim trigliseridim çok yüksek. Do they still say it? Yeah, that is, triglycerides are fats, and they are long chain, and they are not, they are saturated. So when you eat something, you have to be careful not to eat oils, fats, which are saturated. So the saturation harms you because of cholesterol, and it's bad for your heart and all the veins. Therefore, you read in papers and on TVs many times that if you eat fish, kapamayalım da kapı bozukmuş, ha tamam öyle kalsın o kapalı. So they recommend that you eat lots of fish because they have much less amounts of saturated fats. So I will give you the percentages of various meat products, which contains different percentage of saturation. Now, when we talk about, let's say, olive oil, it doesn't have a single compound, single fat, single oil. It's a mixture of various oils. So when you talk about palm oil, it is also similar to olive oil, but the composition of the oils are 6-7 different kind of oils are in there, depends on the plant. But the problem is that when we talk about fat, they are saturated. Unsaturated, when unsaturated oils are liquid oils, but when they are saturated, they are hard. Suppose that we have something like this. If you have many double bonds, or of course, in many cases, they have something like this. But so when you have many double bonds, it's good for you. But if you saturate them all, no double bonds, it's harmful for you. So when they talk about triglyceride, because they are mostly saturated stearic acids. With the glycerin attached 3 stearic acid. That's why triglyceride, that means 3 stearic acids attached to glycerin, triglyceride. So all the doctors recommend you not to eat too much fat, animal fat or butter. So you have to limit it, and they recommend to eat fish. And salmon fish is the one which have the lowest amount of saturated fat. But of course now salmon is very expensive, so you can eat maybe hamsi or any other. So therefore we have to be careful not to eat too much butter and fat if you want to protect your heart and the veins. Okay, so this is a triglyceride, stearic acid, or fatty acid. You can see that all saturated. This is fat. Also, fat is not only one compound, but this is stearic. C17H35, COH, hatırladınız mı? C17H35. So this is, if you eat this a lot, it's very harmful for you. Now, if we want to produce sodium, when we mix a base, strong base like sodium hydroxide, we produce a saponification reaction, and we obtain sodium stearate. I mean, soap doesn't mean always stearic acid ester. Other ones are mixed. But we just give it as an example. And in many books, as I said, when we talk about soap, this is the example that you see, because most of the soap is produced from the fat, from stearic acids to triglyceride. And there is special property of this saponification reaction. Do you remember from organic, any kind of saponification? Saponification means alcohol plus acid, right? Organic alcohol and organic acid is saponification. But there is something special about that. When you carry out esterification or saponification, you have to be careful. Did organic professors tell you what you have to do with these reactions? Organik aldı mı herkes? I'm sure they mentioned, but you should, if you just force yourself, you'll remember. Saponification and esterification. Hiçbir şey hatırlamıyor musunuz? Nereye koydum ya? Okay. I made a mistake, a simple mistake. What should I do when I write this? This is acid. This is alcohol.
It's an equilibrium.
This is ester. Sorry?
It's an equilibrium.
Yeah, it is an equilibrium reaction. So if you carry out an esterification reaction in the lab, it's an equilibrium. You cannot obtain 95% or 99% product. What do you have to do?
Boil off the water.
Yeah, if you remove water all the time, so the reaction then becomes efficient, okay? So it's a reversible reaction. Now, if you look at olive oil, these are the compounds in the mixture. These are fatty acids. I'll give you the percentages. I think I have the percentages in another table. Oleic acid, palmitic acid, alpha-linolenic acid, palmitic acid, stearic acid. What is this? Arachidic acid and anoleic acid. So these are the main components of olive oil. Now, if you look at the fatty acid composition of animal triglycerides, you can easily see that now it's not a good slide, unfortunately. When you look at these, this is from the salmon and the other fish, sardine. They have very high percentage of saturated oils. Black is unsaturated oil. As you can see, butter, lamb, beef. That's why they say at least eat beef rather than lamb, because lamb contains much more saturated acids. And butter is even more dangerous. So we don't say that, don't eat butter. I'm not a doctor, but of course, you can easily tell here as a chemist that if you eat too much butter, that's bad for you. So, of course, we are not rich enough to eat salmon every day instead of butter. Of course, you have to eat beef or even lamb, but not all the time. Now, as I said before, it is sweet, and some diabetic patients, the doctors give them some artificial sweeteners, and some of them contain glycerin. Glycerin doesn't harm the diabetic patients as sugar, but of course it has calorie. Since it's a carbohydrate, it has calorie. If a person is very fat and has diabetic, then it may be harmful to take too much of that kind of artificial sweetener which contains glycerol. But of course, there are always arguments about the artificial sweeteners. But in many cases, the companies, you don't have to trust all the companies which produce various medicines because of the competition between companies. When you use, let's say, sweetener A, and then there's a big fight between two companies, they say this is harmful, that causes cancer, things like that, and you are scared and you switch to the new one. It's because it's a different brand. So that's what they do all the time, the big companies, unfortunately. They lie to people to earn more billions. But what can we do? We don't know which one is true. I mean, maybe the new one is harmful. Maybe they're right. We don't know because of the competition between the big companies. We always get confused. Now, as I wrote down, this is the esterification and saponification reaction. As we see, it is pardon. Kapatmayı unuttuk yani telefonu. Now, if you look at the soap, here we have the sodium laurate salt, which is soap. If we look at the structure, one side of the molecule, in general, if I draw it like this here, that's how the soap cleans, because when we have dirt, as I said, dirt is mainly oil, and there are some particles on it. This part, the nonpolar stearate, let's say, C17H35, let's say, is nonpolar. So nonpolar likes nonpolar, polar likes polar, right? So oil repels water, water repels oil, because water is polar, oil is nonpolar. So if you want to mix something with oil, you have to use something nonpolar. You can use ether, because ether is nonpolar, but you cannot use alcohol, because alcohol is polar. Water is polar. So when you have a dirt, there are some particles. When you have oil, it sticks into nonpolar. It sticks to the oil and surrounds it. We call it missile. So soap surrounds the dirt by immersing the tail of the molecule into the oil. And then the polar parts are left outside. It's like a sphere, right? Outside we have polar head, CO minus or CONA. And inside, all the dirt is covered with non-polar tails. Outside is polar. And so soap did its job. All it needs is water. So if you have water around it, when you wash it under the tap, all the fat goes away. It removes the dirt from your skin because it surrounds, the soap surrounds the entire fat by immersing the tail, non-polar tail, into the dirt, and then all the dirt goes away with water, goes down the drain. Oh, here I have given the diagram, just like I tried to explain. We have the dirt on the skin and also bacteria attached there. That's why we have to wash our hands very often, because when you have dirt, oil, bacteria likes oil. They just attach there. And then you have non-polar, polar. Then they stick the non-polar tails into it. And then when you wash away, bacteria is gone. So if you used alcohol, also, that's why we use colonia more often than many other countries, because somehow we got the habit of using colonia in our houses. I don't know if you still get visitors to your mother's house. Does she still pour colonia? It still works, yeah? But we are the only country, probably, maybe some other few more Middle Eastern countries do that. Germans, they never heard anyone pouring colonia to the visitor, or even themselves, they don't use colonia so often. But it's a good habit. It's good for your health, because you remove the bacteria, because it ruptures the membrane of the bacteria, denatures, and then bacteria is killed. Also, when you have the viruses, also. So soap and alcohol, they are good to remove all the bacteria and viruses away from your body. Oh, here we have the missiles, as I have drawn, or I tried to draw. We have the oil particle, the non-polar tails stick to it, and then the polar heads. Then we have the water, and it's just washed away, together with the viruses and the bacteria. Okay. Now, maybe I should talk about it next hour. Let's take a break, and then we start to talk about the effect of alcohol and soap on coronavirus.